For section 6, we're going to go ahead and combine section 6 and 7. They are closely related. It involves factoring, as you can see. And even then, it's not too long of a lesson. Again, we'll be seeing things you might have seen before. So let's get started. So the greatest common factor, this is an important thing. Now, let me tell you why we're going to need it. If we had, for example, a expression that read 8a cubed b plus 4a squared times b, and they asked you to factor something out, we want to find the greatest common factor, right? So that's going to be our first step over here on the left. We're going to have to factor out the greatest common multiple of all the terms. If you don't know what the terms are separated by the addition and subtraction symbols. So this right here is the first term, and then this right here is the second term. Right, so we're going to have to factor out the greatest common multiple. In this case, we'll call it the greatest common factor. It'll be 4a squared times b. So that's what we're going to have to factor out. Why? Because both of these terms do have a 4a squared times b. They both have a 4. They're both divisible by 4, since 8's divisible by 4 and 4 is divisible by 4. We also have a squared in both of the terms. In one of them we have a cubed, but on the other one we only have a squared. And then they both have b. So we can take all that out. So second step is basically to find what it is you can factor out, the greatest common factor, and take that out. So what would that look like? That would look something like this. We took out that 4a squared b, and left inside is 2a plus 1. Now, you can check this by multiplying this 4a squared b by 2a, so that it gives you 8a cubed times b, and you can multiply it by 1, so that it gives you 4a squared b. Right, so we can double check this, which is nice. Now, factoring quadratics. Factoring quadratics, there's a lot of different methods. A quadratic is an expression that looks like this. So there's an a squared plus bx plus c. The important part, quadratic, means that there's an exponent of 2. That's the highest exponent. That's how we know we're dealing with quadratics. Now, this is the way I've done it. My whole life I've gotten my degrees in math, and it's always worked. Trial and error. What do we do with trial and error? We got to find numbers that multiply to give us c and add to give us b. So what's that going to look like? So say we're given a problem where they want us to factor x squared plus 5x plus 6. Right, so this is of that form. This is of ax squared plus bx plus c. A is 1, b is 5, c is 6. And they're asking us to factor. Now, we have to find numbers, again, that multiply to give us c. In other words, numbers that multiply to give us 6, right here. So, to do that, let's go ahead and find factors of 6. What multiplies to give us 6? Well, we know 1 and 6 give us, if they multiply, they give us 6. We know 2 and 3 multiply to give us 6 as well. And if we add the numbers, 1 plus 6 would give us 7, and 2 plus 3 gives us 5. Now, which one are we going to need? Well, we're going to need the factors that add to give us b. In this case, it's this 5. So our two numbers are going to be 2 and 3. What do we do with those numbers? What we do with those numbers is we put them in parentheses, two binomials being multiplied, x plus 2 and x plus 3. Now, if you multiply these two binomials, they will give you x squared plus 5x plus 6. So that's the one thing to keep in mind. Multiply numbers that give c and add to give b. Now, in this case, a here, let me erase so it doesn't look too messy. But a in this case is 1. If you look at this right here, there's a coefficient here of 1. When we have a coefficient of 1, It's fairly straightforward, the factoring. However, how do we factor when a is not 1, when it's greater than 1? Let's take a look. Let's go ahead and continue with these factoring quadratics, and we're going to have some rules. All right, the first thing is to multiply. Our first terms when multiplied must give us the number a of ax squared. I'm just going to put it here as a reminder, plus bx plus c. The outer and inner terms added must yield b. The last terms when multiplied must yield c, so pretty much the same things. And then the most important part, trial and error, right? That's how we find our factors. So steps without an example are pretty, I don't want to say useless, but it's hard to visualize. So let's go ahead and go over an example. So 2x squared minus 3x minus 9 is going to factor out to 2x plus 3 times x minus 3. How do we figure that out? Again, trial and error, right? So we know from our first step, the first terms, 2x and x, multiply to give us 2x squared. What else? As the second step says, 2x, can I reset? No. So 2x times negative 3 would be negative 6x. And then 3 times x would give us 3x, which would equal negative 3x. So that's why there's a negative 3x here. And the last one, step 3 tells us the last terms must yield c when multiplied. So 3 times negative 3 gives us negative 9. And again, we figure this out by trial and error. Keep working until all the steps are fulfilled. I'll just leave another one here as an example. You can check that. And please feel free to try problems on your packet to get this trial and error. You know, you'll start noticing patterns and get better at this. Now, this was factoring quadratics. There's also something known as factor by grouping. So again, we're going to give steps and examples. So say, for example, they gave us a problem where we had to factor 3y plus 5ty minus 6k minus 10tk. Now, just looking at that, we probably feel like deer in headlights, right? We don't know how to even do this. Well, that's why we have steps. First things first is to group two terms in parentheses. So what does that mean? That means that's going to look like this. We got the first two terms, parentheses, second two terms, parentheses. Oh, I should have done this. And then right here in the middle will be a plus sign, which is over here. So 3y plus 5ty in one parentheses, and then the next two terms in the other parentheses. Okay, next step is to factor out the common factors. So what can we take out from 3y plus 5ty? Well, not much. We can only take out y. From negative 6k minus 10tk, we can take out negative 2k. Now, notice how these two, 3 plus 5t and 3 plus 5t, are the exact same thing. So this is where we group the binomials together. We're going to have one where we have 3 plus 5t, but the other one, as the arrows show us, we're going to have y minus 2k. We're going to group those two together. That's why it's known as factor by grouping. All right, we're grouping things together, and we get our factors. Okay, and last thing we need to go over are some special cases. Again, with practice, you start noticing them. I didn't really use them throughout school, although they are a great tool to have. I'm sure I would have used them if I had internalized them, but I didn't practice it enough. Luckily now I can recognize these patterns. So we have difference of squares. This is one of the first ones. So we have difference of squares, and whenever a polynomial or an expression, if we have an expression of this form, a squared minus b squared, something squared minus something else squared, then its factors are just a plus b, a minus b. So for example, if we just have x squared minus b squared, then its factors are just x plus b, x minus b. But let's look at one that's a bit more interesting. Say we have to factor 4x squared minus 25y squared. Do you see two squares there? Something squared minus something else squared? We do, but we also have to remember to include the coefficients, and this is what I mean. We have 2x squared minus 5y squared. All right, a common mistake I see sometimes is students might say sorry, give me a second. 4, then x squared minus 5y squared. Oh, sorry, I'm writing the wrong numbers. Minus 25y squared. So then they think the factors will be, well, actually, let me show this first before I confuse you guys. These factors here, didn't write them down, but this will end up being 2x plus 5y and then 2x minus 5y. So now I'll mention the common mistake. Common mistake is to put this as 4x plus 25y, 4x minus 25y. So we always have to consider the coefficients as well, not just the variables being squared. So let me go ahead and erase the wrong so you guys don't get confused, whatever's wrong. And now I have a question. If we have x squared plus b squared, well, this doesn't really work. Why doesn't it? Well, it's not a difference, right? It's a sum of squares, but you can try to factor that out and you'll see that you'll run into some problems. Now, there is also something known as a sum and difference of cubes. I'm going to just go ahead and put that up here. And what does this look like? It's basically telling us here what the sum of cubes is going to look like and what the difference of cubes is going to look like. So if you're to have something of this form, a cubed plus b cubed, your factors would be right here. And I'm just going to show you these examples. X cubed plus y cubed, well, that just expands as our binomial and the trinomial to the right. And then the trickier example, if we had a difference of cubes, 8x cubed minus 27y cubed. Remember, we always consider the numbers as well, the coefficients, the 8 and the 27. So we get 2x cubed minus 3y cubed, and that just factors out as our, well, I'm not going to say it, but our binomial and our trinomial being multiplied. So those are these special cases, the difference of squares, and then the sum and difference of cubes. So again, go ahead and practice, and if you have questions, don't be afraid to ask.